Hello, everyone. Thank you for joining. Can everyone hear me? Okay. All right. Hello, everyone. Thank you for joining. Let's get started. So this um, workshop is going to be about understanding how to use nested data structures in SQL. But before we get into that, let's go ahead and set up our code spaces. You can also run this locally by cloning the repository and running Jupyter Lab. It's pretty straightforward, but we'll run it on code spaces just because it's much easier. So go ahead and click on this green button. It'll take a while for code spaces to set up our requirements. So in the meantime, let's go over kind of the key ideas that we want to cover here. So if you go to concepts, nested data types, and click on this Python notebook, that's going to be like the main notebook we'll be following. Um, so while CodeSpaces is being set up, let's go over what's happening here. We will use DuckDB to demonstrate how to use nested data types. And for the data model, we will use something called TPCH. It's like a popular data model that's used for benchmarking different data warehouse systems. So if you see benchmarkings against different warehouses, this is typically what the data that's used. And it's essentially a car part seller warehouse. So you have orders, and an order can have multiple line items. So if you place an order, you can have one or more items. And then you have information like customer details and supplier and part details and some nation and region. The main ones to think about are orders and line items for our kind of use case. All right. So let's see if our code spaces is started. Can everyone hear me? I just want to make sure that you guys are able to hear me. You can let me know in the chat. That'd be great. I guess people can hear me. Let me see. There are a few people, so okay. I'm gonna assume everyone can hear me, unless of course there is something else going on. Should be relatively straightforward to hear me. Oh, yeah, I'm not audible. How about now? Is that better, Deep? Can you hear me now? You should be able to hear me better now. Okay, great. Sorry about that. All right, let's get started. So this workshop is about understanding how to use nested data types. So let's take a step back and understand what is nested data types, right? So when we think of SQL, we think in terms of tables. So if you take a look at this image on the left, you see kind of like the standard SQL table where you have let me see, open this one. So this one's what we're talking about. On the left side, you see kind of the standard SQL table where you have kind of individual columns, right? So you can have like key and dimensions, whatever it might be. And on the right hand side, you can see how customer data is being compressed into a single data structure. Let me move this for you. So in this case, it's customer. So we are combining all the attributes of customer into a single column, and it looks like a dictionary. In DuckDB, it's called structure. There are type structure and untype structure, but essentially the idea is combining related attributes into a single column and representing it as a data structure. You can think of it as like a dictionary or list of dictionary, which we will also see. So that's the key idea that I want you to take away from here. It's like you can store data as advanced data structures and not just individual columns. And we'll see kind of how to do that and why you might want to do that. So the first thing is, if you want to kind of create a wide table, you want to join line item and with customer data and supplier data, this is what you would typically do. You do a left join, you'll take the fact table and join all the dimension table, also known as enrichment. So let's go ahead and run that. Oh, we actually have to first run these setup. So let's go ahead and restart this. Let's go ahead and run this Python setup. If you get a prompt, just select Python environment. So this sets up our data. This establishes connection to DuckDB. And this is just like a check query to see our tables are there. Great, we have all our tables. This is our data model right here, and let's go ahead and run this query. So what's happening here is we are kind of taking line item data, which is L underscore columns, and left joining all the dimensional data. This is also called enrichment. You can see there's quite a bit of columns, pretty straightforward, right? You have customer data and supplier data, so you can see customer and supplier being joined. Now, while this is easy enough, in real projects, you won't have these kind of C underscore names. And if you do, you have to rename it to customer name, customer address, and similarly, you have to do the same for supplier name, supplier address. So the number of columns can become unruly, and it can become really hard to understand the data at a glance. So an approach here you could do is use structures. So let's see how that would work. And the format varies by database, but in DuckDB, it's called a structure, and you can define kind of like the key value pairs within that structure. So we are doing similar joins here. We are left joining dimensions to our line item table, but instead of having individual columns, we are putting them together in a struct or a dictionary. So let's see what that looks like. So here you can see kind of the customer structure, if you will. So all the attributes about the customer is enclosed in that single column, and similarly for supplier. So you might be wondering why this, right? So there are a couple of reasons you may want to do this. One is it makes discoverability and usability much simpler. So now all you have to do is say select customer.id from this table, or select supplier.id, instead of doing select and kind of figuring out what the column name is. It gives you like an encapsulation of your data, makes it easy to access. So that's a key benefit of using kind of these structured these data types in your standard SQL. So that's one. And taking it a bit further, these structures or dictionaries can be nested, meaning you can have dictionary within a dictionary. So let's take a look at this, right? So we have customer, which is similar to what we just saw, but in addition to kind of customer, we also have another structure within the customer called nation. So if we look at the data type, right? So you have customer, and customer can have nation and region. Similarly, supplier can have nation and region as well. So here we see how we can pack nation inside the customer. So now think about it, right? We don't have to name it something like customer underscore nation underscore name. We can just say customer dot nation dot name. This is a much easier representation, even when we are creating and when we are accessing the data. So let's go ahead and run this. See what that looks like. Yeah, we have all the line item columns, and we can see here the customer data type. And within the customer data type, we have a nation key, and the value is a nation data structure or nation struct. So in a sense, we are kind of combining all the necessary attributes of customer in one column. And similarly, you can also see we do the same for supplier. So it's not just one dictionary. You can have nested dictionaries. And as we will see, we can also have array and list. So let's go ahead and see that. But before we go there, I want you all to take like 5 minutes to add region. So we added nation, but also note that nation can join to region. So I want you all to take a few minutes, update this query. So in addition to nation, you can have another structure within this nation structure called region that should have all the region attributes. That way you can say customer.nation.region.name. Right? That makes it much easier to access. So I'll put like 3 minutes on the clock. And if you can't complete, that's totally fine. I have the solutions here as well, so you can kind of go through it at your own time and see what the solutions are. But I want you to try to see if you can do that right now. Easy approach would be to copy paste this and just add region here as an extra key value pair. Also, if you have any questions, please let me know in the chat. Any issues with writing the query, or any other questions on what we have seen so far? Okay, there seems to be a question. Is this struct pack there in MySQL driver and others? So every SQL database these days have some sort of struct type. It depends on the database. You'll have to kind of search for it. If you wanna, let's see if MySQL has database struct data types, right? Easy way is just to look at the data types and look for like JSON or advanced or nested data types. Let's see, numeric string, spatial, JSON. JSON is not typed, so I wouldn't use that. But Postgres has it, so I guess you'll have to explore it. But Postgres has it for sure, which is much easier to use. All right, let's move on. So the next pattern is using a list, or in this case more specifically array of elements. So what happens here is that when you have a table with multiple grains, meaning a row is representing kind of more than one item. So for example, in this, if you look at the left table, you can see that we have one row per item ID. So order 1 in that above example has 3 items, item 1, 5, and 113. And order 2 has one item called 225. Now this is fine, but the problem is when you do group bys on such a table, you can accidentally cause duplicates if you aggregate by total price. So if you consider the left table and you want to see like what is the total price per order, if you're not super careful, you can say select order ID, comma sum total price, and group by order ID. You'll have duplicate order total price, because in this case it'll be order 1 300, which is not true. So when you are mixing grains like this, it's very, especially in like a numerical setting, it's very confusing and you have to be very careful while using that. An approach here is to use an array um, of items. So you can think of it as a list from Python. So you can say array of line items, right? So what are we doing on the right table is we are having one row per order, and each order has an array of items that makes up that order. So if you see order 1, you have 3 items in the array 1, 5, and 113. What this does for us is that it makes group bys easier, and it makes usage of this table much more intuitive. Now you know there's one row per order, and there is 3 line items for the first order, 1 line item for the second order, etc. So let's go ahead and see how this actually helps. So here we are just creating like a simple table here, right? And then what we are doing is we are computing the number of line items, right? So here, this is how you do it, right? You kind of create a structure for line item, and you use this function called array aggregate. So you're grouping by order and aggregating all the line items into a single array of structures. That's essentially what this does, and then you're joining with orders to get the order metrics or dimensions as well. So you can see here, you know, you have order 1, blah, 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 order attributes, and you have 6 line items, and all the information is in this one column, right? And similarly, order 2 has 1 line item, and so on and so forth, right? So what we are doing here is essentially combining 2 fact tables. We have orders, we have line items. Now we are combining them at the level of orders and putting and not losing any information. That's critical, while also enabling easier use of this table. That's essentially what we are doing here. One thing to keep in mind is the size of the column. So in this case, we have 6 line items, that's fine. But what if an order has like 10,000 line items? I'm just giving an example. You need to be careful that your database engine can support that before actually implementing it. I would recommend checking that. Okay. The next section is going to be how this actually helps in data processing. But before that, I'll leave like a minute on the clock for any questions you might have. So please let me know if you have any questions in the chat. Okay. Oh, okay. You will. Thanks. Any other questions? All right, seems like there are no other questions, so let's continue. So the next part is using these nested types, basically structures and arrays of structures in data processing, right? So let's go ahead and create a table. Up until now, we have been just using select queries. So let's create a table with this order table, basically order, list of or array of line items table, right? So let's go ahead and create that. Okay, that's created. Okay. So as I mentioned before, you can get easy access of your data. So we don't have to say customer underscore name. Sometimes the naming conventions may not be great, so you will have to do like C underscore name or cust underscore name, all this confusion. With this sort of approach, your naming conventions can be so much simpler and cleaner. So you just say customer.name. You could also say things like customer.nation.name. So let's go ahead and do that as well. I can say like customer.nation.name. See how easy it is to kind of use this data. And if you have a list or array, you can just use the array indicator. Note that in DuckDB, it starts with 1, not at 0, as in most data or as in most of the languages. So you can see here we say customer.name, it's coming up as name and address and name too. You can rename it if you want, but the access pattern is much easier. And you can also see we are pulling out the first structure in the line item. And you can kind of do this, take it a step further and say line item. You could just say first line item, I don't know, quantity. You can just say line item dot. There you go. So you're pulling out the quantity. So it makes access so much easier, more intuitive. You don't have to remember every column name. You just have to understand the entities um, in the uh, table. There's a question asking, will it provide any way to handle null values? Yes. So there are a couple of things to understand, right? When you say null values, let's say quantity is null, right? So for example, let's see if there are any null here. There are no nulls. You can handle null as usual, I don't know, like callus. But if you access a column that doesn't exist, then it will throw an error. So for example, if you say customer dot, I don't know, so something non-existent column, right? This will throw an error because it's not part of the data model, if you will. So if you take a look at this, when we define customer, we have the standard keys, and only those are accessible. And this is because those keys are data type specific. So what DuckDB will do is it will assign specific data types to those columns. And you can think of it as like columns, right? So standard column. You cannot just access an imaginary column. It will not work. Similarly, structures are also typed. That means each column has a specific data type associated with it, and you need to access it properly. And the other thing is, if you access something like line items 100 when it's not there, it'll throw a none because 100 is not there. So it depends on what you're accessing. Array, you're accessing a value that's not there, so it'll give you a null. But if you access a column that is undefined, it will give you an error. So kind of taking it further, right? Let's take a look at this. So if you say, what is that, describe, this table is called wide orders, right? We can see the data type here, right? So it has to be very specific. We are saying kind of it has to be like the specific data type. So you want to make sure that it has, oh, I think it's truncating at 10. That's why we are missing customer, but you can see here how each key in the structure has a specific data type. So you can almost think of it as like standard column. So same way, it works the same way. I hope that answers your question, DB Prashad. All right, so the next thing is sorting, right? So we know we can sort standard table by one or multiple columns at a time. But when we think of structures, it's a little bit different. When we sort by structures, what happens is that, let's consider an example, right? If you're sorting by these two, right, what will happen is it'll sort by the first key value pair. So 1 and 1 will be the same, and then it'll consider the next key value, part key, and use that value as the sorting criteria. So if you sort by a structure, it'll sort by the values in order, and the order is defined when you actually create the structure. So if you're sorting by customer, which is what we are going to do now, what will happen is it'll sort by ID first, and then name and address and so on. If ID is the same, it'll use the name. If name is the same, it'll use address and so on. So it just uses the values in order of which it is defined. I'm gonna leave like 3 minutes. So here we do sorting by the customers. How would you sort line items, right? So there is a function in DuckDB for sorting line items, or sorting arrays. So I want you to take a few minutes to go through DuckDB documentation to see what function it is. Look for array aggregate functions. That will give you some idea of what to look. And I want you to sort line items and understand how line items are sorted. Hint, it will be similar to what we just saw. You can also ask me any questions in the meantime, or if you're having difficulty running the code, please let me know in the comments. Any questions? You guys doing the query, writing the query? Any questions with writing the query or finding the function on DuckDB documentation? Please let me know. Okay, there seems to be no question. Again, the solutions are available in solutions.ipython notebook in the same folder. So you can go ahead and kind of take a look at that and you'll be able to see the solutions there. So the next kind of approach here is understanding how to kind of convert an array of items to individual rows and vice versa. So if you kind of looked at this code here, what we are doing is using an array aggregate to pack together all the line items into a single column. The alternative of that is called unnest. Basically take an array of items and separate it out into individual columns. So unnest and group aggregates are kind of like the vice versa of each other. So kind of having this idea that you can convert an array of elements into individual rows is critical because that is a pattern that most people do not use. So let's take a look at this, right? So we have wide order table. What we are doing is we are unnesting. What this will do is this will give us one row per line item by the order key. And then we are also doing some extra stuff here, but this is the important idea here. So let's go ahead and kind of run this separately. So we can see line item is split into individual line items. So if you say 8, because I know that order key 1 has 6 items, order key 2 has 1. We can see all the 6 items here as individual rows, and 1 line item for 2 and 1 line item for 3. So you can see how unnest kind of takes this array of elements and split it into individual rows, and group by with aggregates does the opposite. Let's go ahead and run this. Yep. And similarly here, we are doing something similar where we are unnesting and just printing out some values there. Okay. So a critical use case for these advanced data structures is the one big table approach, where you join a fact with all the dimensions and you generate pre-aggregated tables, also known as summary tables, from that one big table. So coming back to our example of having order and line items in one row per order, you can imagine how this can be used to kind of create line item aggregates by unnesting and grouping, and order aggregates by just grouping. We'll see an advanced feature where we don't have to unnest and still process array of items. So the first one is kind of getting line item metrics. The standard way is to take that array of line items, split it into individual rows, and do processing to get line item metrics. So you can see here, what order 1 has 6 items, and the total quantity of all the items in that order is 145. However, there are typically when databases offer this functionality, they also have functions that allow you to work on array of structures. So in this case, that's what we are doing. Note here, we are not unnesting the line items into individual rows, but we are just transforming it as a whole. So here we can see we get order key, number of line items, and total quantity, same as before, but before we had to unnest. However, here we are using transformations and reduce functions to kind of compute the same without having to split them into individual rows. This would be much more efficient, because in the splitting up we have to split and then group by, so you are doing distribution of data sets. Here we don't have to do that, we can just transform directly. If this looks a little bit tricky, it's not, so let me go over this. Right, so what's happening here? So the first transformation we are doing is we are taking that array of line items and transforming it into array of quantity. So instead of considering the entire structure, we only want to consider the quantity, right? So that's what we are doing. We are not, we are kind of ignoring all the other attributes. We are only considering quantity. And then we are doing array reduce. What reduce is that it'll just do a sum. Reduce is a functional approach. You can think of it as just summing these two. So yeah, let's see if array sum works. I'm not sure if that's something that DuckDB supports, but let's see. Yeah, that doesn't exist. So let's see if there is a function called array sum. That should give us something. Array functions. Array functions. Is there a sum? No, there isn't a sum. So an extension of array, we can also try list functions. Let's see if there is a sum. Probably not. Let's just see if we can do some. Yeah, it doesn't work. So yeah, explore the different functions available. YouTube comments is blocking my view. Oh, thank you. Let me just move that. How about now? Is that better? All right, sorry about that. What was I saying? Yeah, so explore the documentation, but every kind of, if a database offers you this ability to kind of see or store data in this format, usually they have ways to kind of compute metrics without having to unnest them. This one is a little bit tricky because it uses like functional patterns, but it should be relatively straightforward in other databases as well. Okay, so the next one is we are just doing group by on orders. We don't have to do any unnest or anything because data is already at the order level. So now you can see how with this approach we can group by a single table while simultaneously calculating metrics from two different grains. So if you take this, right, and you kind of join this, let's do that here. In a sense, we are getting order metrics with this and line item metrics with this, and we don't have to do any special flags or anything like that. What am I missing here? Line items by name. Group by one. Oh, yeah. There we go. So you can see how we are kind of order key. Let's do this just to be straight, make it easier to understand. Okay, you can see it's the same answer, right? 145.38, similar to this one. So we can see how with one table, with two grains, order and line items, we can do a group by in a single kind of query without having to unnest and do all the complexities. So that's what I want you to take away from this approach, is that instead of storing two separate fact tables or a single fact table with two grains, you can use this data structure where you can store as an array of structures or however you like, and kind of do the aggregates in one single query without having to do complex querying and then unioning them, something like that. Okay, So here we created a table called what is this? Wide orders, which is pretty straightforward. We just join a bunch of facts and dimensions to it. I want you to take a few minutes to join all the tables. So take a look at the data model here. We joined orders, line items, customers, nation, region, and supplier. I want you to also join part supplier and part. I'll leave like 3 minutes on the clock for this, but it can take longer. So if you can't finish it in 3 minutes, that's totally fine. You have the solutions in the folder as well. So I'll just leave like 3 minutes on the clock for now. Again, if you can't finish it, solutions are there too. So you should be good. All right. Let's see if there are any questions. Oh, thanks, Naren. I appreciate that. Yeah, the nested data structure is interesting because people think, when we think of SQL, right, we think in terms of tables. We don't really think in terms of Pythonic or dictionary and lists. So kind of incorporating that, I mean, not always, when it's appropriate, I will definitely kind of make a lot of things easier when used appropriately. A lot of databases these days, especially like warehouse style databases, have these advanced features. DuckDB, it's really impressive because they have so many data types, and they have a lot of functions that help us work with those data types. Trino is something that has this. Spark has this. What else? Snowflake has this. Redshift has something similar. I'm not 100% sure. BigQuery has this and a lot more. So if you're using BigQuery, check out BigQuery utils on GitHub. That goes over a lot. Just kind of have this idea that you're not limited to just rows and columns. You also have rows and columns that are a little bit more advanced or nested, if you will. Does anyone else have any questions, or do you guys have difficulty running the queries? Please let me know in the comments. I'll give like 3 minutes for you guys to kind of create this wide orders table v2, and then we'll look at the final part of this workshop. All right. If you're done with the exercise, that's great. If not, that's fine. The solutions are here. Let's move on to the last section. So we saw a lot of how to kind of unnest or group rows into a single column, or store group columns into a multiple columns of the same attribute entity into a single column, etc. Right? But there's a cost for all of this. I mean, there's the storage cost. So you need to be aware of those. You need to kind of make sure you're not blindly using these. For the most part, it should be relatively simple, because in a sense you're just storing the data in a different way. All the engine or database has to do is split out the structures into individual columns. So in most cases it should be fine, but I would strongly recommend kind of looking at the query plan. So let's take a quick look at the query plan, right? Oh, this is limited, huh? I'm not sure. It should be displaying everything. Give me 1 second. Okay. All right, this is good. Better. Okay. So when you do query planning, you read from bottom up. Let's see what's happening here. And this is just one block. It's just due to some sort of issue with Jupyter Notebook. This is kind of has this indentation, but essentially that's just one step. So let's go over this query plan. Right, it's scanning the wide orders table and picking out 2 columns and unnesting. So we have an unnest here, so it's splitting up line items into individual rows, and then it's selecting these 2, right? It's selecting the order key and the unnested line items, and here it's doing some compression before it just so projection is essentially when the database engine does some transformation on top of the raw data, and this is where our second part of the thing happens. Instead of just doing line item, it's doing a structure extract. Again, this is a very low cost operation because the structure is there or dictionary is there. It's just accessing a key value pair O of 1 performance, so it should be fine. The main one is the unnest is the problematic one, and then it's converting it to big int, decompressing to big int. These are like internal stuff we don't have to worry so much about, and then it's doing an order by. So essentially the main thing we have to worry about is unnest. So let's see if we can write this without unnesting, right? So what's happening here? We are doing the wide orders and doing the count. So what if we try to do this, the one where we use array transformations without doing the unnesting? Let's see what the performance of that is, right? Let's go ahead and do that. So this kind of whatchamacallit, you can see the percentage SQL. That's just like a Jupyter Notebook thing where I can kind of write raw SQL and assign it to a Python variable. That's basically what result is. Let's see what the query plan for this is. Remember, the unnest is the most kind of expensive one. Oh, I forgot to explain. See? All right, let's see what's going on here. So again, we don't have to do unnest here. That means we are not converting a single row into multiple rows, which is an expensive operation, and then doing joins. You can see here it takes the sequential scan and immediately does projection. Again, projection is a database engine task that basically takes data you have and does some simple transformations on it. This is typically like a single row transformation, meaning it's very efficient. It's also called narrow transformation, meaning each row can be transformed independently of the other. So this is very low cost. This is like almost O of 1, so it's pretty straightforward. You can see how using the unnest, it's much more expensive than using native or database specific transformations that kind of allows you to do aggregates without kind of splitting up an array of line items into individual rows. So with those approaches, with these sort of techniques, we can make our processing much more efficient. Albeit code being a little bit more complex, that's something, a trade-off you will have to make. Yeah, so we started with, to recap, again, you can see the recap in the outlines here. That's a good place to kind of see the sections in the notebook, right? We saw, we set up a system, we saw the data model. We kind of went over how to use nested data types, so like structures for storing related data into one single entity, into one column, and also you can have like nested structures. And then we saw array for for storing one-to-many relationships, in our case order to line items. And then we saw how with structures we can just access data easily with notations like customer.name or customer.nation.name. And we saw how sorting them sorted by the order of the values. And then we saw unnesting and group by to convert an array to multiple rows or vice versa. And then we saw how this can be used in one big table with and without unnesting, and we saw how without unnesting the performance is much better. So one thing I want you to take away, the main thing I want you to take away from this workshop is understanding that you don't have to always stick by rows and columns. You can also stick by rows and advanced data type columns such as structures. or list of structures or array of structures. Now the naming structures and list, it might be called slightly different things. For example, in DuckDB, list only allows items of the same type, whereas array allows items of the different types. One has to be limited size. You have to predefine it. The other one can be unlimited. So there are some nuances, but for the most part, dictionary and list of dictionaries are a very strong kind of pattern to have in your tool belt when you're kind of doing aggregations, especially. They're very helpful. So yeah, that's it. I'll stay on for a few minutes. Please let me know if you have any questions. The link to my kind of like free email course and my newsletter and blog post are all in the description below. So check it out and let me know if you have any questions. I'll stay on for like 5 to 10 minutes if there are any questions. And thanks everyone for taking the time to join. I really appreciate it. It's a Saturday, so thank you. I mean, the questions don't have to be related to this. If you have any questions with data engineering or data in general, I'm happy to answer as well. So Narayan, the reason is a lot of people reach out saying the time is a lot. So it was like six full whole days of weekends. They said they cannot commit, and the cost was also a lot. So a lot of people said the cost was too much for them. So the main things were time and cost. So a lot of people reached out. So I decided to not do that for now because I don't want people to not take it because it's too expensive or they can't commit to it. So I will be releasing a self-paced one in the future, but I have to record it, so that's gonna take some time. Yeah, sorry about that. Oh, also don't forget to switch off your code spaces. You only have like a limited um, free per month, so you can switch it off like so. Go to your repository. In this case, if you fork this, it'll be whatever you want to call it. Go to code spaces, click on this, and click delete. That way, you're um, saving the cost or the free tier, if you will. All right. If there are no more questions, let's stay on for a minute. Oh, there's something. Oh, yeah. Not sure, Narayan. There's Thanksgiving coming up, and I'll be out for like Christmas, so probably sometime early next year would be my guess. I'm also hoping to chunk it up into individual courses like Python and SQL and Databricks with Spark, etc. That way, people can pick and choose what they want instead of kind of having to pay for all of them. Um, just some thoughts. But I will consult with the people who read my newsletter because last time I didn't do that, and that's why we have the cost and time issues. So make sure to do that this time. All right. If there are no more questions, thanks again everyone for joining. I really appreciate your time. Um, if you have any questions, please feel free to reach out to me at through my website startdataengineering.com or kind of send me a DM on Twitter or LinkedIn. Oh, Naren has a question. Is this struct available in Postgres? Yes, Postgres has type structs. Yep. So you can go to most kind of modern databases have that. So go to composite types. They just name it differently, so make sure to kind of read through those before kind of using a data type. So there are like minute nuances. So please make sure to read them before using them. So here, right? So if you go to Postgres, we can see we have arrays similar to ours. They call it composite instead of structures. So we go to that, and it's a little bit different here, right? So we have to define composite and then use it. If I remember correctly, they have something like struct. Yeah, I guess it's called composite here, where you have to define and use it. I haven't used it in Postgres, so I can't tell. I can't speak to it right now. But the key idea here is always read through the documentation before using it, because with these latest or more advanced data types, there's always some nuances that you need to understand. For example, Trino has its own version of it. Spark has typed and untyped. Make sure to use typed, things of that nature. So please read the documentation before using it. All right. If that is all, thank you everyone for joining. I really appreciate it. Have a good rest of your weekend. Bye. Thanks,